Polynomial functions, and we talk about linear graphs, which is super cool. So the stuff you learn in grade 9. And in math, I guess maybe I should tell you the secret. The word linear means straight. So really what we're looking at is a straight line graph. Or the data falls in a straight pattern. So when we're talking about linear, it's a very mathy word, but it's just really meaning straight. Okay, back to this. So rectangle number 1. What's the perimeter of rectangle number 1? We know that each is a centimeter this way. This is a centimeter, that's a centimeter, that's a centimeter, that's a centimeter, and that's a centimeter. So how many centimeters? Perimeter. So all we're doing is adding up around, we're just adding up the sides. How much do we have? 6, right? 1, 2, 3, 4, 5, 6. So the perimeter is 6. Okay, rectangle number 2. What's the perimeter on this one? 8, yeah. I bet you guys are pretty excited. And if I'm looking at rectangle number 3, what's the perimeter? 10, yeah. Some of you guys are getting really good at this because if you're like, okay, this side is 4, so that side has to be 4, so that's 8, and then I got 2 ends, so that's 10. So I don't have to count every single side. I know stuff about rectangles. Okay, number 4, what's figure 4? What's the perimeter of this one? 12. Or did you guys start seeing the pattern here? What's the pattern? We're increasing by 2. So if you know the pattern without the picture, what's the perimeter of the 5th rectangle? 14. We're just adding 2 on. And if we were to do the 6th, it would be 16, right? Like, so that's what patterns help us do. Okay, so we are going to graph this data. Now, this, do you guys know your x-axis and your y-axis? I don't know where my pad of paper went. Found my pad of paper. Okay, so we call that a coordinate plane. That's called a coordinate plane, and it's super specific. It's something that we use a lot in math. The horizontal is our x-axis, and the vertical, so horizontal lies flat. Again, another mathy word, but really it means it's going left to right, lies flat. Vertical is up, down. Up, down, this is our y. And when we graph a point, we have to label these increments. Maybe this would be 1, this would be 2, this would be 3. These all have to go up. These all have to go up in the exact same amount. So each tick, each increment, each tick is worth the same amount. And those are the positives, but we also have negatives. This one would be -1, -2, -3, -4 right there. What's this right here? What's the value right there where I put that dot? 0. It's super special point. It's called the origin. It's where the graph starts at 0, 0. The x is 0, the y is 0. We call that the origin. You guys probably did some graphing in grade 8 and grade 7? Yes? No? Maybe? Anybody? Has anybody graphed? Has anybody graphed? Okay, you did a little bit of graphing, which is awesome. So we know a little bit about this. We always graph first the x, then the y. So we would go, if I have a point 3, 2, if I have the point 3, 2, we go over 3 and we go up 2. and that would be my point. Okay, so just so you remember, just a refresher about graphing, super important. Are you guys good if I pull that off? You didn't need to copy that. That was just a refresher. Make sure we're all on the same page. All right. So the graph also shows a pattern. After the first point, each point in the graph, 1 unit right and 2 units up. We know that. We know that from our pattern in our table. So that goes up by 1. That one goes up by 1. Goes up by 1, right? We know that the left-hand side goes up by 1 and the right-hand side goes up by 2. If we place a ruler over these points, luckily I've got a ruler. If we place a ruler over the points, what you'll see is they line up in a straight line. If I were to connect them, they line up in a straight line. Okay. We do not join the points because the data that's given, they're discrete. Okay, here's the deal. This is what you need to know. Put a big star beside it because you always have to ask yourself, when you graph something, is the data discrete? Is it counted? Are there values in between? Or is it measured? So if I'm counting people in this room, how many people are in this room right now? 3, 5, 6, 7, 8, 10, 12, 13. I make 13, right? Can we have 13 and a half people? No, that's not nice. That's not nice to cut somebody in half. It's not nice. So we would say we couldn't connect the points because there's no values in between. We either have 12 people or we have 13 people. We don't have 12 and a half people. That's bad, oh bad. Continuous data. So if I ask to measure your height, I wanted the heights of everybody in here. Can we have half values here? I think I'm 5 feet and 3 inches. I don't know what that is in centimeters. But we can have half of an inch. We can have half of a foot. So we can have parts in between. So if something's measured, it's continuous, and we connect the points. So let's write this down. Discrete data. Do not connect. Do not connect points. And continuous data, we connect the points. So I'm going to say discrete data, an example of that is number of people. Number of cars, you don't want half a car. Continuous data is like something if we are measuring the height. Measure heights of people. We can have parts. What about dollars if I want money? Can we connect those? Can you have parts of a dollar? Yeah, cookies downstairs in the cafeteria are only 50 cents, right? So we can have parts of a dollar. So that's continuous, that's measured. Discrete data is when it's counted. You can't have half of something. You should not have half of a cat. It's bad. Okay, so the equation is given here. The rate times by the number of the rectangle plus 4, which is super cool. This tells us how we calculate the perimeter of a rectangle. All right, here's what you need to know. That second variable here, that's a dependent. Dependent. We use that to be calculated by the independent. Uh-oh, I'm running over things. Independent variable. So independent is on the x-axis and dependent is on the y-axis. Do you guys remember which one was x and which one was y? Is x horizontal or vertical? Horizontal or vertical? Horizontal. And our dependent goes on the y-axis, so that's our vertical. So up, down, and this one is left, right. That's a lot of stuff to cram in there, guys. I've written a lot of stuff on these notes. I hope your notes, you got some color, or you got a highlighter, or you got something that keeps it together. Okay, let's graph. This one was done for us. Let's graph. All right. Oh, we should mention, we talked about this a little bit. When the graph of the relation is a straight line, we say it's a linear relation. When things are connected together, it's a linear relation. So it's going to result in a straight line. If you lay that ruler on your graph and those dots line up in a straight line, you're golden. All right. Here we go. So this is the table of values is shown on the cost of renting a DVD at an online store. Graph the data. Does it make sense to join the points on the graph? So we're just going to graph the data first, and then we'll talk about it. Look at this. This is already figured out for us. So what do we put on the x-axis? Do we put the number of DVDs, or do we put the cost? Usually our independent, our x, is in the left-hand column here. This is usually our x and this is our y. Now, not always, because sometimes tables go horizontally, but in a vertical table, this is usually where we go. So we're going to put the DVDs on the x-axis. Oh, sorry, you can't see that. And on the y-axis, we're going to put our cost. Okay, are you all using pencil? Maybe I should move to an erasable pen just in case I make a mistake. Or use an erasable pen. Okay, the first data point. The first data point is, we got to graph this guy. $1 and $3.50. Bless you. So if 2 is here, 1 is right here, and 3 is right here, and 5 is right here. Sometimes I like to have all the numbers labeled so I don't get confused. Sometimes when you're graphing a lot of data. So we're going to go over to one DVD, and we're going to go up to $3.50. So $1, $2, $3. So I'm going to be right in the middle between $3 and $4. Everybody got that graphed? And if it makes more sense to you, do the 1, 2, 3, 4, and then 5, and this would be 6, 7, 8, 9. If that makes more sense to you to put all the numbers in there, sometimes that helps my brain. If you guys can see it, that's awesome. Okay, for 2 DVDs, so we're at the 2 DVD mark. How much is that going to cost us? $7. So we're going to go 1, 2, 3, 4, 5, 6, 7. That's exciting. Drop my other dot on there. Oh, as my ink dries, my dot gets better. That's cool. 3, we're at $10.50. So I'm just going to pop up to that 10 line because that's already labeled. And I'm in between 10 and 11. I'm halfway in between 10 and 11. So I'm going to drop my dot on there. Oh, that's cool. I'm watching my ink dry while you guys do this, and my dots get nice. They look really bad at first. And then I'm going to do 4 at 14. So I'm going to start at 10, and then this would be 11, 12, 13, 14. I could have went to the 15 line and backed off one if I wanted to. And then 5 DVDs, I'm at 17 and a half. So there's the 15 line, 16, 17, and I'm halfway in between. Okay, so now I have to make the decision whether or not I connect my dots. But I want you guys to finish drawing your dots. So get your graph done. Are we going to connect these points? Okay, money I can have parts of, right? I can definitely have parts of money. Can I have parts of CDs? Should I buy half a CD? I don't know if that's possible. I don't think it's possible. I don't think that would be a good plan. I don't think it would play very well in a DVD player. Oh, I just jammed my hand into somewhere. Oh, that hurt. That hurt. Okay, so we have to make a decision. Connect or not to connect? Connect or not to connect? Okay. We can't rent, we can't buy, we can't use half a DVD. So even though there's parts of this one, we can't have parts of this one. So we're going to say that this is discrete data. Discrete data. And that means do not connect. I guess we do not connect the dots. We do not connect the dots here. All right. What is B? B says, is the relation linear? Is it a straight line? Looking at these data points. Whoa. Whoa. So excited about graphing. Is this a straight line? Do the data points, if I put a ruler on it, would they be a straight line? Yeah. So we would say for part B, yes. The relation is linear. Because if I put my ruler right on that, they line up really, really good with the ruler. Okay. Use the table to describe the pattern in rental costs. How is this pattern shown on the graph? Okay. This is the pattern that we want to see. What's happening from here to here? We're going up by ones. What's happening on this side? What's happening on this side? We're going up by $3.50 each time. All right, $3.50. Okay, how do we relate that to the graph? Well, this is how we relate it to the graph. What's the distance between here and here? What's the distance between here and here? 1. And we put the number of DVDs on the x-axis, and they're going up by ones. So this is going up by ones. What's the distance from here to here? So I'm at 350, and now I'm at 7. There's a difference of $3.50. So the pattern is shown on the graph. The change, what's happening in the x values is shown right here. It's a 1. The change in the y is shown on the y column. So it's increasing by that same amount every time. Okay, good job everybody. Way to graph. We got one more to do. Do you guys want to, oh, maybe not. Okay. Example number 2. We've never done one of these before. We've always talked about like situations like renting DVDs and stuff like that. So now what we're going to do is we are going to use an equation to create a table. So we don't know what X and Y represent. We don't know if they're number of text messages. We don't know if they're number of people or the cost. We know nothing about this information. This is a lot what we do in intro. Putting things to situations, that's more what we do in essentials. working with formulas, that's what we do in intro. So if whatever makes the most sense, you kind of know where you're going with those math classes. Okay, so here we've got this. It says create a table of values for the relation where x goes from -3 to +3. So all that means is when I put my table together, I'm going to start at -3 and I'm going to count up to +3. So -2, -1, 0, 1, 2, 3. Oops, sorry. All right, now we gotta calculate our y values. We're gonna calculate our y values. So what we're gonna do is we are gonna take our x value and we're gonna substitute it into the formula that's been given. So where is my, go back to here for a sec. Gotta grab my formula. So the formula was y equals 6 minus 3x, and our first x value was -3. Yep, of course. All right, so we're going to substitute. We are going to substitute -3 into here. So we're going to have y equals 6 minus 3 times -3. So we are going to have y equals 6 minus a -9. Because I'm timesing those two together. When you're subtracting a negative number, what happens? We change the sign. So y equals 6 plus 9. Y equals 6 plus 9. So y has a value of 15. So that's going to be positive 15. So those two numbers go together. -3 for the x and y is 15. Okay, you guys try -2. I'm going to pause it and see if you can figure out the y value for -2. You might need your whiteboards or a piece of scrap paper to do this. I need more room. Can you try and figure out what that is? So you're going to substitute, not -3 this time, you're going to put in there. -2. Yeah, try that. Use your whiteboard. Okay, keep going. So now instead of putting -3 in here, we're going to put in -2. Okay? Give it a shot. Awesome. Good. Nice. No? When I attempt it? You're leaving at 10 too. No, you were leaving 10 minutes early. Required, which is the second.
Just because we have to go talk to our teacher.
No, the list has already been sent. You don't need to tell any teachers. No.
But like,
Which is fine, but you don't have to tell your teachers what to do. So you're gonna just change this number here to -2, okay? Sure. So that's what I got for the second one. That's what I got for the -2. And so my table is going to be -2. If I do -1, what's -1? So if I want to do -1, I'm just going to put same equation. The only thing I change is that x. The only thing I change is that x. Yeah. No, finish this. Finish this and then you can go. We only have a short bit of time left. I used so much time. Minus a -3, y equals 6 plus 3, so y equals 9. Can you guys do 0 in your head? By just looking at it? Who said it? What?
6.
Yeah, 0 is 6. Because what's 3 times 0? What's 3 times 0 if I put a 0 in here? What's 3 times 0? 0. What's 6 minus 0? 6, right? So it's easy ones, right? Like I like doing the easy ones. Okay, next up is y when it's 1. 6 minus 3 times 1. Oh, now we're in positive numbers, so that feels a lot better. So that's just a subtraction question. And then I have y equals 6 minus 3 times 2, so y equals 6 minus 6, so y equals 0. And then my last one, I'm running out of room, y equals 6 minus 3 times 3, so y equals 6 minus 9. Okay, you can go if you want. Feel like we're racing against the clock. Okay, so I filled in my table of values with all that math I did. Do you have this table of values there? Do you guys have that filled in? Good job, everybody. Okay, so we have created the table of values. Look at us. We're golden. Now we gotta graph it. Okay, you guys are just gonna graph the points. I'm gonna start with this one, -3 and 15. So x's, remember, are always left to right, and y's are up, down. So we start with -3, so I'm gonna go over to -3, so there's -1, -2, -3, and I'm going up to positive 15. So there's my dot right there. Okay, graph the next one. Graph all of them. Don't wait for me. Graph. You graph, I'll graph. It'll be great. -2 and 12. So I'm going to 10 and I'm going up 2. Okay. I'll let you guys graph. Sorry, I could just get so excited. If you're not sure about graphing or how to graph, please make sure you come see me because it's super important. Like if you didn't have a ton of experience with it, totally not your fault, but we need to get you better at it, so we're gonna work harder at it. Okay, should we connect the points? Should we connect the points? Yeah, we should connect the points. How come we should connect the points? Because we don't know anything about this graph. So if we don't know any information, we're going to go ahead and connect the points. So I'm going to use a handy dandy ruler. And I'm going to stop there. Look at that. Isn't that pretty? So pretty. Is this relation linear? Is it linear? Yeah, it's a straight line. Pretty easy question to answer. Yeah, it is linear. So, and the pattern is in the graph. These are going, these are going up by ones. These ones are going, what is happening here? What's happening here? We're going down by 3. We're going down by 3. So from here to here, we're going down by 3. And what's happening with my line? It started really high, but it's going down. Okay, that's graphing. I need you guys to practice this weekend. Okay? Make a really good effort to get this graphed. Do your homework is what I'm saying.